Hey guys, we're gonna go and do, I believe, live coding session number 4, and we're just gonna knock out a few problems. So I'm gonna just, in a normal course of practice, try to do each problem in 17 and a half minutes, and yeah, see if I could do it in a rapid pace. So let's get started. So this first one, 103 on Leetcode, and I'll also be doing this on Python. So let's just do this. Given a binary tree, return the zigzag level order traversal of its node values, i.e. from left to right, right to left, and for the next level and alternate between them. So basically, if you have this binary tree, 3, 9, 20, 7, 15, and if that had a level, like let's just say 22, 23, okay, yeah, so basically what I'm thinking immediately is just doing like a simple breadth first search, and then you probably would want to have an additional variable where you're determining the order in which you're adding these levels. So obviously you're printing my levels, and then you want to control the direction. So on the first level, go left to right. Next level, right to left, then left to right, depending on how deep this binary tree is. So in order to use a breadth first search, I'm going to be using a queue. So two things you can do there. You can actually just mimic a queue using a list or Python array, or we could actually just use the deck data structure from the collections library. So I think I might use the collections library. So let me just do import, from collections import deck. Okay, so BFS. So let's go take up some memory. Okay, so with that, let's create the deck, or basically the area we're going to append and remove the elements here. So for the first case, let's do deck, and then we'll have the root be the first node right here. And then we'll just do a simple while loop, while q, and then we'll have, what we'll have here is we're going to want to pop the first element in this deck. So with that, I'm trying to see, because it, like with this output, they want the values to be in their own little list. So I might have to create like a sub output array at each iteration. So I might have to track what level we're at. Yeah, I'm gonna have to track what level we're at. So with this, so maybe with this I have an object. So root level and then 0, and then close that object right here. And then output equals this. Okay, and that's what we're going to be returning. Okay, so you might be asking why I have object and why I have levels here. The reason is let's say you're at the third level or fourth level, you have a lot of different amount of nodes. So like when you're using this queue, you want to keep track of that level so you can know what to combine as you're adding these sub output arrays into the overall output. So return output. Now before I get anything done here, let me just make sure. Okay, so let's just say if root is none, then we'll just return an empty array. Okay, so we just have a simple base case right there. Okay, so now we just want the cur node to equal q dot pop left. Okay. Oh yeah, and then we want to have that variable, so left to right equals true. So like basically as we're adding the children, in this case like left to right, then we're going to we're going to like switch the left to right variable to false. So then it's going to go the opposite way. So we'll have like two branches of code or conditionals within that while loop to determine how to append to this deck object right here. And then of course at each level we're going to add that by 1, so we know where to add it to the subarray. Okay. So I should have a little subarray, sub output, like I was saying, sub output equals sub output right here, and then if left to right, and then else. Okay, so we got our two branches of code. So if it's left to right, then we check if, if it's left to right, then we just check if cur node root dot left is not none. I'm gonna do the right one right too. So we're basically just checking both children. So in this case, I just check that. And then that's where we're gonna add the level. So like level 1, level 2. Okay. Okay, so q dot append root. So again, putting that right there. And then for the level, you're just increasing it by 1. Each level goes down. Oh, and I forgot to do the stopwatch. All right, well, I'll just say I have half the time there. So level plus 1. Okay, so with this, I got to make sure that I'm doing this correctly, so I have to actually have cur node level plus 1. Okay, so and I also have to have some type of condition where once this level is changed, so like let's say in the actual queue, like you go from level 1 to level 2, then that sub output is attached to output. So for example, so maybe you gotta track like the current level. So yeah, let me cur level equals 0. Okay. So if cur level does not equal cur node dot level, then what you want to do is output dot append sub output. Okay. And then after you do that, you want to change the current level, the cur level to that. So basically you're appending it, acknowledging the new level, and then as you're going through the queue, if the level changes again, then you have these elements. So this is the 0th level, this is the first level. When you go from 9 to 15 in that queue, then it's going to append these two numbers and then these two numbers, and let's say you just have like multiple elements on the other like nodes, so then it might be do 3, 4, 2, 1 elements based on if they appear as children. Okay. So after you add these, then you want to change the level. So left to right equals not left, not to right. This kind of just reminds me of JavaScript, because JavaScript, instead of like just using that not, you have like the bang or exclamation point right in front of it. Okay, and the same thing here after you change this. And then all you change is the order here. So from there, now I got to make sure that we're appending these elements. Ah, okay, gotcha. So sub append. Okay, sub output dot append cur node. And let me just make sure, because I gotta make sure if they want the values. Yeah, the values. Okay, so root dot val. Okay. Okay. Cur level equals cur node dot level. Perfect. Then you add these. These go in different order. Okay, so we're pop left, that's great. Or you can just do pop 0 as well, so you could do same thing. So let me just make sure I am doing this correctly. Okay, I think this might be good. Let me just do a once over on this. So from here, zigzag level, we have a base case, so if the root is none, return empty array. We use the deck object, or the deck data structure from collections. Then you just use object to collect the level. Once that level changes after you pop that first element in the queue, then you input this sub output, and actually we gotta have that be empty now. Okay, then we change the current level. Then if that passes, if we're on the same level, then we append that. Depending on this this condition right here, we either go to left to right or right to left. And then based on that, you return the output eventually. So, oh, did I call that wrong? Maybe it's just collections. So cur node. What did I do wrong here? So cur node level. Okay. String indexes must be integers. So maybe I should just do this. Okay. Maybe I just misspelled it. Okay, so cur node, pop left. Okay, so what am I doing wrong here? Okay, let me check the time. So I think I have 2 more minutes to get this solved. String indexes must be integers. Q.pop left. Oh, maybe I just have to do pop. Okay, let's just do pop. Okay, so current node, that's spelled correctly. So q.pop, pop left. Okay, maybe I just have to do it based on normal array, and then like we'll just simulate it then. Okay, so from here, just do that. Remove this dec function, and then we'll just reflect that right here. So pop left. Maybe that's the issue. Okay, so don't have pop left, so we're just going to replicate that with pop 0. So pop the first element. Sub output is not defined. Let me just make sure where I misspelled that. And again, you want to check this before you actually do an interview, so not the best practices by me, but let's see where I made a mistake. Output.append sub output. Okay, so you can see here it just returned an empty array. It should return these, so I gotta find out what the issue was here. Okay, so maybe it's just I have it before. So it's added 9. Why doesn't it add the other ones? Okay. So from there, I add by 1. Okay, level, root, that looks, oh, that's why. That's why you have to be careful how you copy and paste. Sorry, guys. Okay. So we're kind of on the right track. So we have 9 and 15, so that's working. Maybe I have to put this back here. Okay, just kidding. Alright, so let's check what's going on here. So at each here, you basically cur level. So from this, like you basically want the increased amount. So cur level 0, this first level 0. So if that's the case, you just go through here. Okay, so you add the sub output. We're adding this. Root.val, perfect, okay. Okay. I mean, this is looking fine to me. So from here, it's only adding these numbers. So from, how do I add 3, 20, 9, and 15? I mean, okay, so it's obviously missing these first numbers. So I'm getting, okay. So I'm missing some type of this this Q right here. So I'm wondering if this level by node is messing it up at all. Okay, I think I got it. Let's just do this. New level. Yeah, so new level. And then let's just replace that right here. Okay. Okay, I'm still having the same issue, so it's not the actual new level additions. Okay, so for this first one, I think I ran out of time. Yeah, so let me just move on to the next one. So next one, I think we're going to be doing number of islands. So let me just reset this. Okay, and we'll get back to this one in a bit. Oh, maybe for this it's because you have... Interesting. Okay, anyways, number of islands. Okay, 200. Given a 2D grid map of ones and zeros, count the number of islands. An island is surrounded by water and formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the graph are surrounded by water. So for this, you are just actually looking for a count, which actually helps out. So you don't have to return like an array of counts, just overall landmass, which is good. Okay. So I'm going to structure this in terms of multiple like levels of helper functions. So for this, I think what you want to do is you want to have like a visited matrix. So that's obviously going to have is this n times n? No. So this might be like row times c space. So sorry, row times column space, because you are replicating a visited array to keep track of like nodes you visited. So let's see, for row in matrix, and then false for call in, actually false for in row. So I've actually learned about a lot of this from Algo Expert, so that's like a great resource if you guys want stuff to kind of be visually explained through videos. If you're more of a visual learner, it's great. So we also have a count variable to count that out. Also, when you do matrices, like what's helped me out is to make sure that you remember basically how you're supposed to align rows and columns to the matrix. So basically, like if you have a laying matrix, I believe that when you're iterating over these different indices, so let's just say like rows is R and then columns is C. So when you're iterating, you're going to want this to be, so for row in range this, and then for columns, you're going to want actually it to be the row itself. So, and that's going to make sure that you don't have like any like out of index errors. So for this, and it's kind of similar to how you're constructing this visited array too. So, okay, so yeah, if you already visited something, I don't think you need to go check it. So if visited, oh, and let me just do grid. I always just like default to matrix. Okay, so for this, row, call, then continue. Else, if that's the case, then you go to your helper function, which is, I think you traverse the nodes and make sure that's part of like a traversal, and then checking its neighbors. So with this, you do traverse nodes, row, call, grid, visited, count, and then you just do return count. And again, since you are just not collecting overall like size of these islands, you're just collecting the overall count. There's a little less like legwork there when you check the neighbors. In the check the neighbors thing, I think all you're going to be checking is, hey, has it been visited? All right, track that down. All right, so def traverse nodes equals rc grid visited count. Okay, so from this, oops, sorry, lost that. Okay, so for this, now what you're going to want to do is essentially like use a stack to check all the neighbors, and then just keep a count of that. So with that, you are going, So let's see, nodes to check, nodes to, or chords to check, because you're checking out coordinates in this grid. So RC, let me just make sure everything's good here. Okay, so with this, now you check while lang chords to check. So basically, again, you're kind of using this as like a simulation of the stack. So you're just checking all the coordinates to make sure that that node itself is being checked, and then also its neighbors. So let's just do check neighbors as well. So, and again, this is more of an iterative approach. Hypothesis for space and time are going to be O times C, and then time, and then O R C for space. So why this space? Because we are creating an equal grid. Why the time? We are iterating through this and then going through these operations as you're going through a nested for loop. Okay, from there, now you're just checking this. Now you have the new coordinates. So let's just say I equals, current node equals chords.check.pop. I equals current node 0, j equals current node 0, okay, so from this, if this current node has already been visited, so let me just make sure. Okay, yeah, so if grid, oh no, okay, yeah, if visited ij, then continue. And then from here, I think you check your count, I believe. Let me just make sure. Okay, so count plus 1 is somewhere in there. So then we check if grid equals, oh yeah, that's after, okay. So like what we're doing here is visited ij equals true. So you're just making, this little first test is just saying, hey, if it's been visited, then just continue through the loop. If it has, hasn't been visited, then you mark it visited, and then from here in the grid, you check if it is 1. So if it's 0, then continue, go to the next one, and then this is where you add the count. And then compared to like other versions of this problem, you're basically just checking the neighbors in order to just check that off on the visited. So hey, it's been visited, and then you're not confusing any of the other like ones and islands. So from here, let's see, neighbors equals check neighbors. So from here, now you're going to want I, j, grid, and visited. Okay. So for neighbors, neighbor, in neighbors, then you just refill the stack up here. So chords to check dot append neighbor. Okay, so from there, then you return count. Okay. Okay, so I just copied this input array here. Okay, and now you check the neighbors. So I believe this is just horizontal and vertical, so you don't have to worry about diagonals. So instead of like having to worry about like 8 different coordinates, you only have to worry about 4. And then you just have to make sure that in the parameters where they're greater than 0 on both the row and column lengths, and then also under the outer boundary of the length of the columns and rows. And then we're just going to return the list of neighbors. So neighbors equals this, and then return neighbors. Okay, so again, just have your up, down, right, left. So let's just do that. Up, down, left, right. Okay, so if you kind of just compare that to like where you're going to be at, then let's just do this right here. So if you're going up, you're doing columns. Up and down are columns. So up, down. So if C is greater than 0, and let's do this. C minus 1 is greater than 0. Oh, actually, J minus 1, I'm sorry, because we changed the indices. And then for this, visited and not visited. Yep. So I is the same. You just, oh, this is gonna be down. Okay, let me just change that. So you minus it by, no, that's going up. Never mind, I was wrong. Okay, so this is less than. Oh no, nope, okay. Okay, so for this, and then what you do is neighbors dot So you don't want to keep adding by 1. You just want to add it 1 once. So instead of that, maybe we can have just a little checker like island found. So island found equals false. That's true. If island found count plus 1. So I don't need that to be returned. I just need that to be ended. So instead of this is island found equals not island equals true, for sure. Okay, neighbors dot append j minus 1. So basically you kind of just copy this process, except you just move the indices. So for moving down, you add by 1 and make sure that it is less than the length of matrix 0. And then you just do this right here. And then you just change that one right there. And then for left, you make sure that you subtract I and then keep j by itself. So make sure that's greater than 0. Change this right here where j is the same. Okay, so make sure that's the same. Subtract by 1 if these conditions passed. And then finally, you just want to make sure I plus 1 is less than the length of matrix. Which is, no, sorry, grid. I keep on going back to the, okay. So, and visited I plus 1 j, and then from there, neighbors dot append I plus j. So basically you're just adding all these neighbors to check. You go through here, once island found is true, so like you haven't passed like false, then you can add 1 to the overall thing. So you don't want to add 1 to the whole thing, just if an island is found. So I think this should work. Oh, okay. I always forget with Leetcode, you got to add self. So self. Oops. So I got to reflect that because it's inside a class, of course. Okay, let's make sure I'm not forgetting anything. Okay, let's see. Got 2 minutes left. Let's see what I did wrong. Okay, maybe instead of island found, I can just do count equals 1. Yeah. Count equals 1. Then it's just going to go on repeating. Okay. So what am I doing wrong here? I don't think I have to return anything now. Okay, so I'll keep on adding that. Okay, what am I doing wrong here? Okay, let's just see my original plan. This again is going to add count plus 1. Oh, I can just do overall count. Yeah, okay. So do I just return? Okay. Okay, so somewhere in here, 1's not getting added. So land count, visited equals true, continue, if this equals 0. So if that's the case, yeah, land count. Okay. Well, it may have been an issue with maybe check neighbors. I'll have to check it out. But guys, thanks for joining my like little live session. Obviously, I have these little one-off errors to check, but yeah, thanks for joining. I'll improve next time. And if you have any feedback from me, let me know. Thanks, guys. Peace.